in this last example, we're going to go ahead and use some formulas. Use the formula degrees Celsius equals 5/9 times the quantity degrees Fahrenheit minus 32 when it is 86 degrees Fahrenheit outside. So, or somewhere. So 86 degrees Fahrenheit, that means we can replace this value, this degrees F, with 86 and go ahead and compute. So I see degrees Celsius will equal 5/9 times the quantity 86 minus 32. By order of operations, I'm going to go ahead and do the parentheses first. Or if you prefer punching this all in at once, just be careful. So 86, take away the 32, is 54. Okay, so 5/9 of 54. Oh, I don't even have to round this answer. That's so nice. Oh, look, because 1/9 of 54 is 5. Wait a minute, is 6, I mean. Sorry about that. 1/9 of 54 is 6, and then 5 sixes is 30. Ooh, no rounding. Okay, so 86 degrees Fahrenheit. So 86 degrees Fahrenheit is the same as 30 degrees Celsius. Okay, nice. So this was particularly chosen to make sure that when you're plugging in values, you really plug them into the right location and into the correct variable. Not to mention that each one of these variables has a very specific meaning, and if you swap them, you definitely have their relationship wrong. So, suppose there's a savings rate of 2%, and you put $1,000 into an account in order to save for your dream vacation when your kids turn 18. Okay, I remember creating this example. This is right after I gave birth. I don't think it was right after I gave birth. I think it's after, like, you have a couple weeks of no sleep, and then you're like, when will I ever have a vacation again? So okay, you put $1,000 into an account, save for your dream vacation when your kids turn 18. How much money will be in the account after it sits for 10 years using this formula to compute for earning simple interest? Okay, well, let's do it. So P, it's all about what value goes in for what variable. So this P stands for principal, which really stands for the initial investment. Okay, so is this being like principal, or should it be like, I feel like this should be AL. I don't know, like a principal with an ELE, that's like kind of like a moral or something you live by, but a AL, that's like the number one. So you know what, let's go like that. Okay, and you can figure out if I'm right or wrong later. Anyway, what are those, homophones or whatever? So the R is rate, and the T is time, just so that I put everything into the right spots here. Okay, here we go. The amount in the account is $1,000 plus, okay, 1,000 times 2%, which is rewritten as 200ths, times the time, 10 years. Okay. By the way, this rate, so if we were going to do this rate is what, 2% a year for 10 years. Right on. I think we're ready to compute this. 1,000, 2% of 1,000 is, well, 200ths would be like 20 1,000s of 1,000. So 20 and 20 10s is 200. Okay, I do not trust myself, so I'm going to go ahead and put that into my calculator, which I fully expected you to do. Yep, thank goodness. Feels good to be right every now and again. So, how much money will be in the account after it sits for 10 years, earning simple interest? Here it is, $1,200. I do not feel like that is enough for the dream vacation after raising your kids for 18 years. Okay. And that's 18 years. I wonder how many of you are 18 or older and living at the parents'. And I'm not making fun of you. I'm just saying that sometimes your parents deserve a vacation, you know? So after 18 years, they certainly do. It's weird because right now my mom's about ready to move back in with us because of the pandemic. But anyway, family. It's different for everyone. Use the formula A equals P times the quantity 1 plus R to the T to compute the amount in the account earning annually compounded interest at a rate of 3% each year for 10 years. Okay. Got it. This is compounded interest. So it's very similar to the last problem, except instead of simple interest, we have a new formula where it says compounded. Oh, let's do it. So the initial is still 1,000, and our rate is now 3%, so 300ths, and that is the constant multiplier of 1.03, and it's being multiplied by 1.03 10 times. Definitely need the calculator. Here we go. Let's see, 1,000, oopsie, now you can't see anything because it's bright. 1,000 times the quantity 1 plus 3% and raised to the 10th power. I'm going to have to round that, but I'm a bank-ish. Well, I just don't necessarily know if a bank would round that to 92 cents or they would just give you the 91 cents. So I'm going to err on the side of caution and say that that means we have approximately $1,343.91 after 10 years. Okay, well that was better than the 1,200, but still might want to tuck away a little bit more. Find the perimeter of a basketball court at a playground, given that the length is 94 feet and the width is 50 feet. And the perimeter of a basketball court is given by the formula 2L's plus 2 lengths and 2 widths is the perimeter of a court. So perimeter is 2, okay, where's L? So L is 94, 2 54s plus 2 50s. Yeah? 2 lengths, 2 widths, all the way around, total perimeter. Right. Well, this is 100, and this is 100 plus 8. So 108 plus 100, 208 feet all the way around for the perimeter. Okay, so now let's write down, we wrote down what a function is. We've previously written down what an equation is. Now let's write down what I think I would write down as what a formula is. To me, it's an equation with 2 or more variables. Okay. Describing a relationship among quantities. Okay, so when I look back and think about the difference between this and functions and equations, So first, equations, they could just have one variable, sometimes two, sometimes more. Okay, for instance, this is an equation, okay, but it has more variables describing a very specific relationship about money, between money, rates, and time. Functions are a type of formula with a very special property of for every input there's exactly one output. Now, here it depends on what you call the input, because there are so many variables here, 1, 2, 3, 4 variables. So you would have to really pin down, what am I calling the input and what am I calling the output? If I input all of these things, what should the input be or the output be? So here, a formula, it doesn't really specify what is the input and what is the output, but a function does. So for instance, I remember we wrote down this. V of t let us know value is a function of the time here. So it was really specific. My input was t and my output is the worth of the equipment. Nonetheless, so we have functions, we have formulas, and we use them all. And a lot of times what we're really clear about is our communication. So if we have this, we're not exactly specifying, in this particular case, we had more than one input, not just one input, okay? But sometimes we can communicate when there's just one input and just one output, and we use function notation to do so. So it's really about all of these notations and really communicating to the reader what we mean about what we write. And that's what this class is all about. Be real clear about your units, be really clear about what you're doing, and sometimes that means writing a complete sentence, such as value is a function of time.